Thankfully, this will be the last actual net environment editing we have to do here. So once we're back over here, we can make another brand new category here. We'll call it points. Then that, I'm going to make all of these are going to be empty points. So I'm going to call this point 1. It's kind of hard to see these invisible objects, just as they are, because, again, they're invisible. But if you click this tab instead, now we can see the kind of thing we can drag around here. I'm going to put that at 10 and negative 20. That looked a little off center. Oh no, let's get that lined up. Oh, they did the dumb thing again. So this did the same thing that the environment did earlier, where the points thing decided to just be off center a bit. That's why it was off a bit. Okay, so now that's in place. So we want the points category to be 0, 0, 0, and then the first point can be 10, 0, negative 10. And now it's going to be very easy to just copy paste these all over the place. Similar to before, except there's only 9 things. I'm going to copy that once, we'll put it at 0. Copy it again, put it at negative 10. That didn't copy right. There. Call this point 2, point 3. I click this again just to make sure they're in the right spot. Yep, they look good. Now just like before, you can copy all 3 of those, paste them down. And now because all 3 are selected, we can change the z-coordinate of all 3 at the same time. So now they're all sent up in the middle now. All those 0.4. The naming really doesn't matter here because we're just doing script references, but it helps keep things organized. Do this one more time, and we'll set them to be Z10 now. So we're at the bottom area. 0.7, 0.8, and 0.9. Now we can see a 0.1, 2, 3, 4, 5, 6, 7, 8, 9. So again, you really don't have to follow this this specifically. This is all adaptive. You could make 4 or 5 points and really do the same thing here. If we look back at the skeleton script component now, you'll see there's a little drop down here for points. And this is how we can fill in how many points we're going to put here. We're going to make this an array of size 9. Fortunately, this is tedious. You just have to do this once to get over with. You have to drag over each of the points into the transform spots. While we're here, we also need to fill in this reference here to the nav agent. I'm going to drag that up here. And now we have everything that we actually need to do actual good scripting now, instead of all this tedious engine and editor setup. Once we're in Unity, first thing we want to do is, right when the NavMesh starts up and the script starts, we want the agent to immediately pick somewhere to go. That way, just right from the start, they just start moving. So the idea is we have this list of points here. So if we just pick a random index from 0 to whatever that last index is, we can just use that reference, or a reference to that point, and say that the destination for the agent is that point. This is all stuff we can do with the references we have now. So the randomness first, we've done that before. We could do something like int rand equals random range 0 to points.length. What we can do with that is we can now say nav agent set destination and give it the value of points at rand dot position. Because if we look at set destination, it's looking for a vector 3. Vector 3 is a coordinate of x, y, z. So just saying points rand alone gives us a transform. Once we say that transform's position value, that gives us the vector 3. So that gives the NavMesh what it's looking for. The only other thing to do now is we set the animator earlier to have a different trigger for walking, or for idle. For now we're just going to walk. we can say anim set and trigger walk. That way, right away at the start, he picks a spot to move to and just starts walking. So now if we go back over and try it out, we're going to need to move the camera around a little bit for this, because right now the camera, I believe, is still set up kind of awkwardly here. So I'm going to move the camera to 0, 30, 0, 90, 180. Oh, I got messed up. There we go. This is a big top-down view. Now we can test it. See if this works. And look at that. So you notice he's still walking. Obviously that's the problem. We didn't do anything to tell it to stop at any point. We told it to find one point, go there, and then just go there. So he eventually gets there, and he stops moving, but the animation didn't stop playing, because we never told the animation to stop. So the NavMesh at least recognized, hey, we got there. But we need to do a little more here. Ideally, we need some way to detect whether the agent is actually at the destination or not, so that we can do whatever we want to do at that point. So the best way that I currently know to do it, which I'm sure there's probably better ways, but we can do inside update, we can check every frame and say if the nav agent remaining distance less than or equal to nav agent's stopping distance. So what that means is it's going to check if the remaining distance on the current path is less than the distance that we're telling it to stop here. What I mean by that is if we look at the component settings for the NavMesh agent, you'll see there's a stopping distance of 0. Which means that it basically has to be within a range of effectively just 0, or a very, very small number, to be considered at that point. Like, that's the point where we say we're at the destination. So increasing that allows for flexibility, so that way you can be a bit further away from the actual destination, and we can still consider it to be done. I haven't had to change that here, it seemed to work more or less fine. But we're checking if the remaining distance is less than or equal to that, so that way we can say if we're in range. So, if that is the case, what we can do for now is we can just have it pick a new random point and just keep walking. We can basically copy the exact same code. The int rand equals random.range, 0 points.length, agent, at destination. We don't need to set the trigger to walk here, because we already did that in start. If you adapted this to have him start and stop as you go across a path, then you would probably want to do that then, but I'm not going to bother here. The only other two things, we can increment our point count. That auto-completed wrong. We can also maybe make a debug statement, just to say, arrived. Point count equals... There we go. So now in theory, once he reaches the endpoint for each path, you should just pick a new thing. Look at that. Yep, and you can see it's navigating and avoiding the cubes. He's steering pretty well, actually, which tells us that the radius of the NavMesh agent was actually pretty well set by default. The first time I did it, he was kind of brushing up against the edge of it and getting really close to the cubes, and the cubes were pushing him out of the way, sort of. Whereas the default version here, he's just steering right around them. So it's very smart. Give it a point, and it just goes there. However, I'm going to go back to the console. You can pay a little more attention to what's actually happening down there when we do this. You can see it immediately went 1, 2. Now it went 3. 4, 5, 6. Now just 7. Just 8. You see, there's not really a specific pattern to it. There is some randomness involved, but you can see what's happening is occasionally he's just immediately saying, we're here, we're here, we're here, we're here. If you think about it, this is really happening because there's always a 1 in 9 chance that you're going to pick at random the same spot that you're currently standing on, which naturally means that it's going to immediately finish. So as soon as you set that destination, it'll say, oh, we're here now. And then we go back in, we increment the point count again, and then we just grab another one. That's something I'm going to leave as a challenge for you to try to fix on your own. It's not that hard. All you need is to have the script regenerate a new random point if that new random point is in the same position of the current one. I will note that I ran into a bit of an odd bug when trying that out myself. I couldn't quite figure it out. If we have time in class, I'll show it, but it seemed to involve that the NavMesh was setting the position of these points off-centered slightly, where they would be set in one position in the real world, or the game world, I guess. But then once it's set in the NavMesh, the height would be different, which meant that it was kind of hard to compare the two because they technically weren't in the same spot anymore. I don't know if that was an issue on my end or not. It happened on 2 different attempts at the project, but I don't know if maybe I just did something wrong both times. So try it out, see if you can get it working. In the meantime, one last thing we can add here. Since we have a point count, even if it's a bit finicky, we can now say if the point count reaches a certain number, stop. So that's just pretty standard C# kind of stuff here. We could say if point count equals, let's say, 5. We also want to check if the nav agent is not already stopped, just to avoid some repetition. Say if and nav agent is stopped. Then we can say is stopped equals true. And we can set the trigger to be idle. That way, not only does the agent stop moving entirely, won't try to calculate anything else, we won't give it a new destination, it'll just go back to the idle animation. Try that out. One more. Perfect. We actually got 2 there. But if we go back to the scene view and kind of zoom in on him in the middle of the game, you can see, yep, he's just standing there in the idle position. So, with that, that is enough to get the basics down for this. There are infinite amounts of ideas you can do with this. The vast majority of my fun doing game dev stuff like this is really just taking these existing kind of demo-y projects and just adding whatever ideas I can think of. And just thinking about how would you do that in code. So I'm expecting that you can do that sort of thing at this point. You're all at least 3rd, even 4th year students, so you're capable of handling code on your own. So I'm trusting that you can kind of extrapolate what kind of stuff you could do from this, and at least know what kind of questions to ask for it, even if you don't know exactly how to do it. So, just mess with all this, see if you can figure out how to get the regenerating to work a little better, see what else you can add to it, and we'll go from there.